So solving compound probability with a sample space. Remember, the sample space, that is like a picture representation of whatever it is I'm trying to do. So for example, if I have a coin, my sample space would be that I can flip heads or tails. If I had a dice that I was rolling, all the numbers on a dice are 1, 2, 3, 4, 5, or 6. Or you could think you could draw out all those cards in a deck of cards, or whatever you have on a spinner. All of those are examples of your sample space. Sample space is, again, just pictures drawn out of whatever you're trying to look for. So if you want to solve compound events with a sample space, there's two things you need to look at. First, or there are a few things you need to look at. First, you want to decide what kind of probability is it. Is it an independent probability where your total is going to stay the same? Or is it a dependent probability where things are going to impact or change the numbers? Once you've decided if it's independent or dependent, then you want to calculate the probability of each event. Each event separate. Each event separate, just like we did before with simple probability. What's the chances of each of those things happening? And then compound probability, we have those two probabilities going at once. So to figure out what it is, we need to multiply those probabilities together if we're doing it algebraically. But because here we're doing it with a sample space, we're just going to be able to see from our picture what the probability is going to be. And then always simplify your fractions. On our last summative, a few people got the wrong answer. They chose 3/6 instead of the simplified 1/2. So we need to make sure we're being careful there. So let's do an example with a sample space. So this one's kind of a big sample space, so I already had it all drawn out there for you. It says you roll a fair cube. If I'm talking about a fair cube, that's the same thing as rolling a dice. That's the same thing as rolling a dice. Find the probability of rolling a 3 and then a 5. So first I need to think. If we go back to our last slide, we have to think. Is this going to be an independent or dependent probability? Independent means the first thing doesn't change, doesn't affect the second one. Does what I roll on my dice the first time change what I roll the second time? No, they don't change each other. Numbers don't go away. It's going to be independent. These are independent probabilities. So the first roll of our dice, that's shown with those green numbers, the big 1, 2, 3, 4, 5, 6. The green is the first roll. The green is the first roll. And then the pink is the second roll. I want you guys to be different colors. There we go. The green is the first roll, the pink is the second roll. So if I'm looking through my problem, it says that first I want to roll a 3. So which is my first roll with a 3? That green 3. That means I rolled a green first. And then I rolled a 5. So this shows me rolling a green first, but I need to roll a green and a 5, or 3 and a 5. So here, that green, and then its arrow going to the 5, shows that first I rolled a green 3, and then for my second roll, I rolled a 5 on the pink. So there's one way that I can roll a green first and then a 5. Are there any other ways I can roll a green first, a 3 first, and then a 5? This 5 and this 3, it's the right numbers, but in the wrong order. I have to roll a 3 first, and then the 5 second. I have to roll the 3 first and then the 5 second, so that one doesn't work. Only this one option of that green 3 and pink 5, only one of those options works. So remember, the top number is what we want. We wanted a green 3 and a pink 5, and we need to put that over the total. We need to look to see how many total options are there. So I can roll a 1 and then a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. And then I go a 2 and a 1, a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2, a 5, a 2 and a 6. That's a lot to count through all those things. So an easy way for you to figure out how to count is whatever the furthest over section is. So here my furthest section is pink. If I just count how many total pinks there are, that's going to be my total number for the bottom. So let's count. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. 36 total outcomes. The outcomes are the total answers. This shows all the different answers that I could get. So my probability of rolling a 3 and then a 5 is one option out of 36 total. One option out of 36 total. So that's how we would solve a problem with a sample space. Draw it all out, and then figure out how many options are there for what you want over the total. That's one way to solve a problem, is using the sample space. In the next video, I'm going to show you a formula that you can use to solve this problem.